This is the last video for section 3.8 here on related rates, and I just wanted to briefly recap our procedures and some common tricks to try for these related rates problems. So just to recap our general procedure here, which we've done in these previous examples as you've been watching the videos before this, right? Right. The first thing you want to start out with is sketching the scenario. If at all possible, sketch it out. It helps. Label your sketch. That gives you a chance to identify your constants and your variables, okay? And to give those variables different names, name them in a way that makes sense to you, okay? So sketch it out and label your sketch. That gives you a good solid start. And identify what you want to find. That way you know when you're going to be done with the problem. Otherwise, sometimes it can be hard to tell if you've done enough or if you've done too much. You don't want to go too far with these. So identifying where you want to end up is a good thing. We're kind of setting up a roadmap here with a picture. Okay. Then in step 2, you need to find an equation to relate your quantities of interest. So you labeled your variables. Now you need to come up with an equation involving those variables. And the tip here is to just try something. And your first try might not always work, okay? That happens with these. It'll get better with practice. There are some common relationships to try that we'll look at in just a second here. But yeah, you come up with something that describes the scenario and the variables you're working with. And then in step 3, you're going to take that relationship, take that equation, and differentiate it implicitly with respect to time t. This lets you create rates, okay, and shows how the rates are related, which is kind of the point of this section on related rates, okay? And at this stage, you'll be able to tell whether the equation you chose is going to work or not. So at this stage, you should be able to find values or be given values for everything except the thing that you're solving for. So if you really can't come up with those quantities, sometimes it does take a little work, but if you really cannot come up with a way to find them, you might need to go back and try a different equation. So at this stage, you have your differentiated equation, and then you should have values for everything. Step 4 is to just plug in those values and solve for your quantity of interest. Okay. And then in step 5, you do a little check to make sure your answer makes sense. And the main things we were checking there was the units. Okay, did the units make sense? Does the sign, positive or negative, of your value make sense? So is this quantity increasing, positive, or decreasing, negative? And then does the size of the value seem appropriate? So making sure that it's not wildly too large or too small, that it's somewhere in a reasonable ballpark. So that's checking if it makes sense. So there's our procedure, and you might have noticed that in these examples there were some common equations and relationships that came up a couple times, or a general theme among some of these equations. So some things to be considering when you're doing step 2 here, finding an equation for your problem. Consider if there is volume or surface area, okay, for a 3-dimensional shape, area regular for a 2-dimensional shape. Those type of formulas come up pretty often because we are sketching different types of shapes, and these different types of shapes have areas and volumes. And again, if you need to refresh those for some common shapes, on the next page here, there's some reminders. Some of the ones that we see most often, by the way, would be your squares, rectangles, triangles, circles, And then I'd say rectangular solids and cubes, cylinders, spheres. Occasionally you might see a cone. We don't tend to see too many parallelograms. So not too many of those, not too many trapezoids, pyramids or frustums. On occasion you might need those, but they are not the most common shapes for these type of problems. Okay. So there would be our volumes and surface areas and general area. Also, we do tend to encounter a fair number of triangles in these problems. So you might need to use your Pythagorean theorem. Okay. And you might also need to use your trig functions if it's a right triangle for these two. Okay, so for right triangles, keep in mind your Pythagorean theorem and your trig functions, sine, cosine, tangent, etc. So those are some of the ones you'll see more often here. So it gives you a nice place to start. All right, so there we are. That is related rates.